Okay, so this week we're looking at confidence intervals. So I'm going to see how many problems I can potentially get through and kind of help you through this and show you where to look for it in Minitab. Um, so, so week 6 homework, so I'm just doing a preview and seeing what problems I see. So for number 4, I'm seeing find a margin of error. Now, margin of error, you'll just have to compute by hand using the calculation in the book. When you see S, that's talking about um, a sample standard deviation, um, which is referring to your t distribution. So because n is 100, usually it's not a sample, but that's what they're telling you here. And actually, the formula is essentially the same. So we're taking the margin of error, and we're going to take um, your Okay, hi everyone. What I'm going to do is go through some of the material in the confidence interval section, which is section 6. So, the first thing we're going to do, we're going to aim towards technology when we can, and when we can't, we're going to go ahead and use the tables. When we're looking at this one and we're asking for the margin of error, the calculation or the equation for this is on page 321. So we have our error equal to our t distribution. So we're going to find that value, and that comes off our chart, times our standard deviation over the square root of n. So for this problem, we see we have a confidence interval of 0.95 and an n of 36. So what we would do is go to our table, which is in the back of our book. It's table 5. If you go to the multimedia library, you can look for the appendix and scroll through until you find table 5, which is the t distribution. And we have a 95% level of confidence, which is here 0.95. And then we go all the way down, and we see that our sample size is 36. And once we go above 30, it actually turns out to be the same as normal distribution. So we're going to pull off that 1.96. Okay, so that's how we use our table. We pull off that 1.96, and that's what we need this confidence. This C equals 0.95 for, and then we're going to multiply it by 3.7 over the square root of 36. So we have 1.96 times 3.7 over 6, and you'd want to get out your calculator. And to do this, and we're coming up with 1.2086, and we need to round it 3 decimal places. So 1.209, and check our answer. And there's number 3. So number 4, I'm going to ask for a similar exercise here. So we want to do a confidence interval. And we have a population mean of mu here, so we're going to go ahead over to our confidence intervals, and we're going to go ahead and use Minitab. Because this is over 30, you're going to get the same number for t distribution. So because it's saying population mean, we're going to go ahead and use our normal distribution. And so we're going to go over to basic statistics, and we're going to do a one sample z because we have a population mean, and our n is greater than 30. So what we're going to do is put in our sample size, which is 47, and then our mean, which is 5.1, and then our S for standard deviation is going to be 0.3. And then under options, this is where you put your confidence level in. So it's 0.90, so you're just going to put in 90. And just leave this alone. That would be if you were doing hypothesis testing, which is next time. And we don't want to perform a hypothesis test. We'll leave it open or off. So again, just don't worry about this. We only care about the 90. And then hit OK. And here's our confidence level right here, rounded 2 decimal places. So we're going to use 5.03. and 5.17. And we're going to check our answer. And there we go. The next one I wanted to look at is number 6. Use the confidence interval to find the estimated margin of error, then find the sample mean. Okay, so the margin of error, what you would do is you want to take your confidence interval, and because remember the margin of error is you're starting with your mean and you're adding the same number and subtracting the same number. So what we need to do is find that margin of error. So we add together that 3.6 plus 4.2 and divide by 2. So 3.6 plus 4.2, I'm just using my calculator, and we're getting 3.9. So this is your margin of error. So actually, that's not your margin of error. That is your mean. So sorry about that, guys. Not thinking here. So our margin of error would be then our 3.9 is in the middle, and if we added 0.3 to it, and if we subtracted 0.3, we would get the 4.2 and the 3.6. So our margin of error is actually 0.3. And then our sample mean is what we found here. So when I took them and added them together and got 3.9, that is our sample mean. And if we take 3.9 minus 3.6, we get our 0.3, which is our margin of error. So our sample mean is 3.9. And that's how we do this one. Number 7. Find the minimum sample size. Needed to estimate mu given C, S, and E. Now, this is on page 310 of your book. And we're estimating sample size to estimate mu. And because we're talking about mu, that's how we know we're talking about the normal distribution. And this is out of 6.1. So this is n equals z. They use the letter, looks like a C. Usually you say C alpha, sigma over the error. And they're always giving us S to use for sigma. Now, to find that Z, if you turn to page 305 in your book, it talks about the level of confidence and then the Z that goes with it. So if you have a 90% confidence level of confidence, you're going to use 1.645 for Z sub C. And then 95% goes with 1.96. And then if you want to be 99% confident, you're going to use a 2.575. And again, this is on in your book on page 305. And then, of course, this one gives us 0.98. So let me look up that one quick. Page, again, 305 in your book talks about how to get these z-scores. So I've just given you the one for 98%, and that is 2.33. So basically what you're doing is you're taking your normal distribution, 98% is in the middle with 1% here, 1% here, and you're finding the z-score that corresponds with 99% because there's 99% to the left. So we're going to go ahead and use that 2.33 times our S over our E, and then we're going to go ahead and square it. And so we have 2.33 times 9.6, and then divided by 1, and then we're going to go ahead and square it, and we're going to come up with n equals 500.33, and you always round up, and they'll remind you to do that. So make sure you round up to 501. If you round accordingly, which means if you actually round down, it won't be high enough, and you'll have, if you put in 500, you'd have a problem. So there is how you do sample or finding the sample size. And again, after you do the calculation, you want to make sure that you round up. Okay. Let's see. I already started with the 90% here, so I'm going to go ahead and do the 95% confidence interval. You have a sample mean, sample standard deviation. And you definitely want to use confidence interval here. So we're going to go ahead. You can use this t-distribution. Again, because the sample size is so high, you'll get the same answer, but because it's a sample mean, we're going to go ahead and use basic stats, and we're going to do a one sample t, and we're going to put in our sample size of 50, and we have a mean price of 141, and our standard deviation is 15.7. We're going to go to options, and we're going to go to 95% because we haven't done that one yet. Again, we're going to ignore this because that's for next chapter. And we're going to go ahead and hit OK. And we did our one sample t, and it's telling us that we have 136.54 and 145.46. Round 2 decimal places is needed. Because it's 95%, we're going to be more confident, so it's shrinking that confidence interval. And let's check our answer. And there we go for number. Then what we want to look at is proportions. So we have, for large sample size, we were using a normal distribution. If you have a sample size less than 30, that's when you're using your t-distribution. If your sample size is large, it's over 30, and use a t-distribution, you'll get the same answer as that using the normal distribution. Then what we have are proportions. So it works very similar, but we're going to use something different in Minitab. So I did the 90% confidence interval, so I'm going to do 95%. So because we have a proportion, you'll know this because there's a survey of so many people, and then out of that survey, how many said yes to something or said no to something. So these, in this survey, 398 said they have gone to the dentist in the past year. So we're going to go to basic stats, and we're going to do proportion. So it's just one proportion. And what we need to do is know the number of events. So how many persons said yes or no out of the total, which is the 619. And then we're going to go to options, and then we're going to do the 95% confidence level. So we'll put that in there. Again, we're going to ignore this because this is for hypothesis testing. Make sure that this is unchecked and hit OK. And then we have our answer there. So 3 decimal places. So again, you want to be really careful that you're rounding to what the question is asking for. So 0.604, 0.681, and check our answer. And then that is how you do proportions. And then the last thing I wanted to look at was determining sample size for these kind of problems. So it talks about the minimum sample size needed if you have a prior study and if no estimate is available. So usually if you're going to conduct a study, you don't have an estimate, so you're just going to get the highest sample size to be safe. So the formula you want is on page 331 in your book, and that formula is n equals PQ and then your z-score E squared. And for this example, you would go ahead and put in the 0.58 for P and then 1 minus 0.58 for Q. And then because it's a 90% confidence interval, we would pull it off that chart and use that 1.645. And then for your error, it's 4%, so you'd use 0.04 and square it. For B, no preliminary estimate, you want to use the .5 for both.